Welcome to all. Today we are starting support reactions for cantilever beams. Remember, simply support beam and cantilever, one main difference. Simply support beam, there are two supports and both can give only vertical reaction. But if you got one hinge and one roller, the hinge support can give vertical reaction and also horizontal reaction. So two supports are there. So what you have done, take moment about this support, you get that reaction. Or take moment about that support, you get this reaction. Now, cantilever beam, don't see here now, first write, class. A beam with a fixed support at one end and with no other supports, only fixed support, is called cantilever beam. See, that's all. No support, nothing here. Other side is free. Or, see, like this. Now, class. Instead of this way, so many people, they tell easy language, a beam fixed at one end and free at the other end is called cantilever. You can write here. Fixed at one end and free at the other end is called cantilever. Now, again class. A cantilever can be fixed at left end or right end. Don't by heart left side, right side. Left side point I will take A, B, A, B. I am not changing name. Now write here. This is a cantilever beam, say A, B, where you should write here. See, what I am dictating you should write. This is a cantilever beam because one side fixed, one side free. And this cantilever beam is fixed at the left side, left end, that is A. So this is cantilever AB with the fixity at A. This is cantilever AB with fixity at B. But do not by heart left and right. Now, support reactions will be only at one end where there is fixed support. See, actually, reaction comes when displacement is prevented. Free end can move, there is no restriction. Where fixity is there, their reaction is there. For a fixed support, see, we are discussing coplanar force system. There can be three reactions. Three. Let it once again, just to understand, because three. Now it is more clear. Three reactions. Three reactions. Namely, horizontal reaction. In our class symbol is H with a suffix. If it is support A, HA, support B, HB, H. Vertical reaction V, and never forget one more, reacting moment M. Never and never forget this reacting moment. Gone case class, I will tell what. In case you forget about this reacting moment, then your structural study, everything, cantilever behavior is completely gone case. So remember, never and never forget this reacting moment. Say M. Or I told you. See, correct, clear. Actually, for a fixed support, in 3D, there are 6 reactions possible. See, vertical reaction, horizontal reaction widthwise, and horizontal reaction lengthwise. One reacting moment this way, one reacting moment this way, one more reacting moment this way. That is for space system when you consider 3D or 3-dimensional force system. But our study is only 2-dimensional, I written here. Coplanar force system or 2D. Because somebody may tell, sir told there are 3 reactions. No, fixed support has got 6 reactions. I will tell him I know it. I will know all those things. I know all those things. But our study is for coplanar force system, 3 reactions. Vertical reaction, horizontal reaction, and reacting moment. And remember, after writing this one, 3 reactions, now write here, this already I told you. You write here, 3 unknown reactions. This all told for you earlier. And there are 3 basic conditions of static equilibrium. Namely, sigma m0, sigma v0 and sigma H0. You can tell reverse order. So 3 unknown reactions, 3 equilibrium conditions. So a cantilever is statically determinate structure. Okay, over. Now, all these are over. I will show you systematically how reaction will come. See, today's class is only for basic concept. Basic concept means how we have to consider a cantilever beam. Okay, now I will rub the board cleanly instead of trying to rub in front of you and waiting for it to dry. Now, consider cantilever beam AB fixed at left end A. Left end is fixed, right end is free. Here consider cantilever beam AB fixed at right end B. Left is A is free end, B fixed end. But I told you never by heart left and right. I always take left A, right B. Okay. Very important, subjected to only vertically downward loading. Subjected to vertically downward loading. Very, very important. That is right now, no horizontal loads. Make a note. You make a note here, somewhere. I will dictate here, you write. Right now, there is no horizontal load. It will come little later when you do numerical solve. Because reason is, we are interested in the reactions which is used for calculating shearing force and bending moment and slope and deflection later. For that, horizontal load is not considered. Horizontal reaction also not considered. These all you will be knowing later. So right now, important, see, vertically downward load, you write here, any type of load. Any type of load. Here also. Any type of load. Type of load. Like you can write here, point load, UDL, UVL, represented by triangle, right angle triangle, isosceles triangle, or trapezium, anything. Okay, but important, see, this way, this way. I told thousands of times, reaction comes at supports. How? To prevent displacement. And reaction is equal and opposite to action. Now, see here. If I take a fixed support here, left side fixed. See here now. If I apply horizontal load, it will not come out. It will give horizontal reaction. If I apply vertical load, it will give you vertical reaction. If I rotate the fixed end, see, it can't open this way. No, it cannot rotate. It will give reacting moment. So, a fixed support, this I already told earlier, has 3 reactions: horizontal reaction, vertical reaction, and reacting moment. Now I will do one thing. Right now we are discussing only vertical loading. So make sigma h equal to 0. See, HA equal to 0. So now forget about HA. It is already over. Here, make sigma h equal to 0, HB equal to 0. Now forget about HB. Leave it. Now we are interested in vertical reaction and reacting moment. What you do is, see, first consider V vertical reaction, actually horizontal, first consider vertical reaction and reacting moment at fixed support. Make a note here. In case horizontal loads are there, then consider horizontal reaction also. But we are discussing vertical loading. Okay, now, how to now right here. How to decide direction? You should write here. How to don't see anything here. How to decide direction? Answer. First of all, does not matter. Consider whatever direction you want. Vertical reaction. You write all these. You can take vertically up or vertically down. No problem. Suppose your direction considered is correct, positive sign will come. If the direction considered is wrong, negative sign will come. So that will take care. What about reacting moment? It can be either clockwise or anti-clockwise. you can consider whatever you want. Suppose you consider clockwise direction. If it is correct, positive will come. Or suppose you consider direction, 1 minute, no clockwise, any direction. Suppose it is correct direction, positive sign will come. If it is wrong direction, negative sign will come. So later you can reverse it. That is there. But, write all this. But it will look very foolish if you consider wrong direction for cantilever. See, simply supported beam, placed this way. If not couple, don't apply couple, apply vertical load. Surely both reactions are up. If couple is there, something else, up. Suppose you take down, somebody will laugh at you. Load is trying to push you down. If reaction also pushing down means, what is this? Reaction should be opposite to action. Therefore, you can take any direction, but better take, if possible, see, I will tell you here, if possible for you, actually possible, if possible, as much as possible, consider correct direction. Correct direction. I will tell you how. See, this load is acting down. See, for a cantilever beam, whether it is this beam or that beam, whichever beam is there, loads are acting down. So that is action. Therefore, reaction has to come vertically up. That's why I took up right here. You write a note here. I will dictate here. Write a note here. I will dictate. Loading is down. It will try to push the support down. So for balancing it, reaction is up. Here also write, loads are pushing it down. So reaction is up. Okay. Vertical reaction over. Reacting moment, be careful. See here. What you do is hold the cantilever beam where fixity is there, make a pin support this way. Put this way. Apply the loading. See, when you apply loading, see how the beam will rotate or what type of moment will come about here. See, it will try to rotate this with respect to fixed support, rotate the beam in clockwise direction. See here, this load with respect to fixed support here, very important. See the fixed support, not free end. Fixed support. Here, fixed support. See here, this loading will try to move, try to push the fixed support down, so reaction is up. Load will try to push the fixed support down, reaction up. That's okay. Then this loading with respect to A will try to rotate in, see, with respect to A, your finger should be at A, not A. Don't by heart A. Finger should be at the fixed support, right there. When you decide direction of reacting moment, your finger should be at fixed support. Hold here. Okay. It will rotate in clockwise direction. But fixed end, see, if it is a pinned support, you can rotate. Fixed, you can't rotate. So when it is rotating this way, the fixed end will give you reacting moment like this. See, this action, see here, action, clockwise, reaction, anti-clockwise. Therefore, for this beam, for vertical loading, since the loads will try to rotate the beam AB with respect to A in clockwise direction, the reacting moment should be anti-clockwise. Or here, see, hold finger here. This loading will try to rotate with respect to B in anti-clockwise direction. This is fixed support. It cannot move this way. So when you rotate this way, the support will give you clockwise reacting moment. Or once again make a note. You hold something here, apply a load. Ask someone to push it down. Then, see, if he pushes down, your hand, you will actually move, you will move this way. See here. Hey, no, this way. Here, see. No, this way. Lastly, I will tell, load acting down, vertical reaction, both are up. The loading on the beam will create, finger should be at the fixed support. The loading on the beam will try to rotate the beam with respect to A in clockwise direction. Clockwise. That is action. When action is clockwise, for balancing, see, you require anti-clockwise moment here. This way. Here. The loading will try to rotate in about fixed end. Finger should be at B in anti-clockwise direction. So, you get what? You get clockwise reacting moment. Therefore, whenever I solve such questions, I will write VA up, MA like this. HA, HB, don't bother. When I beam is this way, I will take VB up and MB in this direction. Now make a note. By chance, if couples are also there, suppose the couple is this way, no problem. Again, same answer. But if the couple is this way, then it will try to rotate in other direction. Then what happens is, you have to decide whether effect of loading more or effect of couple more. No, do one thing. You consider this way only. If mix up loading is there. By chance, if this direction is wrong, that is possible only because of couple or upward load. Then when you solve, negative sign will come. So what direction of reacting moments at the fixed support you assume, in case it is by chance wrong, you will get negative sign. When you get negative sign, what you are doing? You are reversing it. So there is nothing to worry. So this is usual pattern for vertical loading. Horizontal, I am not bothered. Okay, now furthermore, last part. Now last part is very, very important. I will tell how to apply the basic conditions of static equilibrium. 1 minute. Now, I forgot to write the heading only. The title is right here. Somewhere you are right. No space right here. I forgot to write title. You write title first of all. I completely forgot to write the title. Okay. I use a color. Somewhere upper side you write. How to find support reactions for a cantilever beam. Cantilever beam. Okay. Right there, heading. Okay. Type it. First, before that one, see. Consider a cantilever beam AB. I will take A here and B here. I actually earlier rubbed it. AB. See, fixed at A. Important. Fixed at A. Consider a cantilever AB fixed at B. That is very important. Fixed at B. See here. Fixed at A. The fixity is important. Fixity is at A. There, fixity at B. Write the two beams. Subjected right now only vertical loading. Make a note. If horizontal loads are there, you consider horizontal reaction. That is nothing to do with the principle. It is simple, right? It will come later. Right now, our most important is vertical reaction and reacting moment. Horizontal is very simple. Okay. Consider, I written here. This is a common statement for both. Consider reactions at fixed support. That is, which reactions? That is, vertical reaction V and reacting moment M. Never forget this one. Never forget this. Okay, at the fixed support M. Now, consider horizontal reaction also if applicable. Now, how to decide direction for vertical reaction and reacting moment? Just now explained. So recollect once again, but he will tell once again. See here. I will not tell each and every class this one now. I will stop telling it. Loading is down, vertical reaction up. You should write it here once again. If you are serious, write here. Loading is down, vertical reaction is up. Over. I am telling maybe 6th or 7th time. Put the finger at A. Loading will try to rotate the beam AB with respect to A in clockwise direction. That is action. See, loading down action, vertical reaction, up reaction. Moment will be clockwise. That is action. Balancing fixed end moment or reacting moment will be anti-clockwise. Here, loading down action, vertical reaction, up reaction. About fixed support, loading will rotate in anti-clockwise direction, reacting moment clockwise. Assume like this. Now, make a note. By chance, due to a couple later, if any wrong direction is there, it will be taken care by the equation. You don't have to worry. Negative sign will come. Okay. Now, over. Sigma H0, see, if horizontal, you write here, if horizontal reaction is there, make a small note. If horizontal reaction is there, apply sigma H equal to 0 and get the horizontal reaction. Over. It is not our problem now. Now, how to get the remaining? Now to decide over now. How to get the vertical reaction VA and reacting moment MA. See, I am making dark MA for this question. How to get VB and vertical reaction MB for this question. Sigma H already over. First apply sigma M equal to 0. Take clockwise positive. Okay, now when you take moment, which point you take? I told from beginning of the earlier, when you take moment, always take moment about the point where unknowns are there. This beam, unknowns are, you should write here. When you take moment about the point where there are unknowns. Here, unknown is at where? A. Therefore, take moment about A. Sigma M about A equal to 0. This question, apply sigma M about B equal to 0. Clockwise positive. Right. We will get MA, we will get MB. We will get MB. Okay. But get with sign. Positive sign indicates direction assumed is correct. Later will come. Next apply. Sigma V equal to 0. We will get VA. We will get VA. Here also. Next apply sigma V equal to 0. We will get VB. We will get, okay. We will get VB. Over. Now, some common statement right here. Once you get the reactions, if you get a positive sign, it means assumed direction is correct. If you get negative sign, it means assumed direction is wrong. On that basis, finally put the result. Okay, this is traditional approach. Class means like earlier, assuming the direction for unknowns, applying the basic condition of equilibrium and solving, then deciding the direction based on sign. This is called traditional approach. Okay. Now, I'll remove everything now. Full I'll remove. There is a shortcut is there. So many times the shortcut is very, very useful. So now I will tell you the shortcut. So those who find difficulty, you always go for traditional approach. Don't go to shortcut. But those people who can afford, who can understand, those who want structural knowledge, they should understand. So I will tell you the shortcut. Full bold, I will write the statement now. Now, actually ink is little faded. You cannot see bright. You take your notes and book and write in dark letters. Use sketch pen. What I tell you should follow. Do not refer here. Don't take screenshot of this one because why? Color is little light. The ink bottle is missing. I am not able to get the red color ink here. One bottle is empty, other bottle I am searching for it. So I managed. But what all red color is there? Write in sketch pen, write. Shortcut or easy or fast method to get reactions for cantilever beam important is vertical reaction and reacting moment at fixed support. Make a note. Horizontal reaction as usual. I will tell last. Okay, now start. First, to get vertical reaction, I will tell only once today. To get vertical reaction at the fixed support, stand outside, go outside, don't go there. You fold both your hands, see, this way. I think you can see me. Do not use your finger, no finger now. See the beam. See, I will tell you. I will make a small note here. If the beam is like this, or if the beam is like this, see what I am doing now. You stand outside. Stand outside. Don't touch the beam. Stand outside and find net or resultant vertical load. How much is total load with the direction? 99% case it is downward, except some rare cases of upward loading is there. Some rare case upward will come, 99% downward only. Okay. Find the net or resultant vertical load on the beam, or that is total load acting on the beam vertical direction, usually down. Find this load. See, load. That is called action right here. This is called action. This is called action. Now reaction. Now reaction. Now reaction. Then directly mark the vertical reaction at the fixed end of magnitude same as that vertically downward load. Action, reaction both are equal in magnitude but in opposite direction. Means I will tell something here, you write here. What I tell you write here. If the net load is 100 kilonewton down, vertical reaction is 100 kilonewton up. See, simply support beam, if you apply 100 here, it may be 60, 40, 70, 30, 50, 50. Sharing is there. Here no sharing. Only one support is there. Everything has to come to support only. So make a note. If net load is 100 kN down, vertical reaction at fixed support is 100 kN up. Write that way. Over. To get reacting moment, now you use your finger. Now finger required. Earlier I told, see, stand away from the beam. Don't touch the beam. Now use the finger. Now find net, put your finger at the fixed support. I am telling again and again. Fixed support, fixed. Right there. Not free end. Take your finger. Put at the fixed support. If find net moment of the loads, of the loading on the beam about fixed support. Net moment with the direction. That is, see, about here, put here. See how much is moment. Now, then, this is action. This is action. Action. Then, directly mark reacting moment at the fixed end of magnitude same as the net moment whatever you got, but in opposite direction. Make a note. I'll stand outside and tell now. If total load is found to be 100 kN down, vertical reaction 100 kN up. Okay, vertical reaction over. If that finger should be at the fixed support. If it is this question, finger should be here. If it is this supposition, finger should be here. That moment point is always fixed support. Write 10 times. When you go for shortcut, your finger should be always at the fixed support. Okay. When you put the fixed support here, if net moment is 180 kilonewton meter clockwise, enter FEM, that is the reacting moment, anti-clockwise 180 kilonewton meter. Or if the net moment is 180 anti-clockwise, action. Reacting moment will be 180 clockwise. That's how to do it, and make a note. Lastly, make a note there. If horizontal force is there, same thing. Net horizontal force, balance it. That is very simple. I will tell later. So now, make a note here. When I solve the questions for simple loading, I will solve traditionally and also by shortcut. At that time, first few questions, I will tell all these by words once again. Then I will stop it. Then I will stop. Then I will tell, if you are not serious, if you are not dedicated, you don't learn from me. I will put the effort. See, I should put 10%. You should put 90% effort. It is not possible. I give 90% effort, you put 10%. Not possible. So now, go through everything. Next class will be a master example. For all this master example. Then, question 1, question 2, question 3, series will come. Okay, see you in the next class. Thank you.